That's why when we have 1.1 here, we talk about the relation that you have learned back in Form 2. Okay, so you can represent it during different ways. Okay, you can using different way, like you can represent the relation by arrow diagram. So what does it mean by arrow diagram? You can see this one, the part one. Okay, it is a one-to-one relation. This one is very common, meaning when you have 1, it becomes 3. You have 2, it becomes 4. You have 3, it becomes 5. So why is it so? Okay, because all these object here, you so call them object, you have add 2 to it. Am I right? So that's why when you have 1, it becomes 3, because 1 plus 2, you get 3. 2 plus 2 become 4. 3 plus 2 become 5. Okay, so that's why what you've done here is what you have done here is actually add 2 to each of the object. Okay. Okay. Yeah. So let's move on. So all these here on the left, we call them as object. Okay, agree with that? Okay. So all these here, we call it as object, where we all add 2 to this object, then they become image. Okay. But this object and image, right? We only use it for what do you call that? Function. Okay. All right. I'm in already, right? I think. Okay. Okay, let's move on. Okay, so now when you're talking about relation, right, it is not yet function, because relation can be 4 types, isn't it? So only there are 2 types that is function. So now we start from the very beginning to recall back relation first. So you have one-to-one, and then you have one-to-many. Okay, so one-to-many here means one object to many relation. I repeat, one-to-many here means one object to many relation. Okay, so like 4 here, can when you have square root 4, please remember to consider the -2 and the 2 as well. Okay, why? Because when you square -2, you get back 4. You square 2, you get back 4, isn't it? So now from left to right, we say that this is one object to many image. Okay, and then also we go on to the third one. Many to one means that you have many object to one relation. So this is like what I have told you. So when you have consider square, right? Actually 2 square, you get 4. -2 square, you also get 4, isn't it? So that's why this is many to one now, because the relation now is starting from 2, you square it, become 4. -2 also, we square it, become 4. So this is many object. Okay, many object here, moving to one image. So that's why it's many to one. And then last but not least, you have this many to many relation. Okay, so how do you get to many to many? Okay, sometimes student will tell me that, oh, it is one to many, or it is many to one. Okay, so basically when you have this one, right? I have blue pen here. Can I write? Yeah, I can write. Okay. So 6 can you see here? You have okay, okay. All right. So 6 hours is equivalent to sorry, the diagram runs a bit by right should be 360 minutes. Do you agree? Okay. And then also you have here 6 hours is also one quarter of the day. That's why it's 0.25 of the day. So basically it's connected to this one and this one, right? Okay, so when this one happened, right, you call this as, this is one object. Oops, sorry, this is one object. Okay, and then you got to many image. Okay, so you say that this is one to many. Am I right? Whereas you can see also at the same time, you have many to one happen here, such as you can have, okay, let me see here. You have another one is 1 minute to 60 seconds. Am I right? And then 2160 second to 360 minutes. Okay. And then, let me see here. Yeah. So usually Many to many happen because you will have one to many, and also at the same time you have many to one, okay, in the same diagram. Okay, so when these two happen, right, you have to counter for these two. In the end, they become many to many. Is it okay? So usually for many to many relation, there will be in the same diagram, you have one to many and many to one. That's why in the end, it end up become many to many. Okay, clear, right? This part, yeah. So this part is only talking about relation. So when we say relation, we can always represent them either the first method, this is called arrow diagram. Second one is called ordered pairs. Means like this one. 1, 3, 2, 4, 3, 5. You write them like your coordinates. Okay. And then you just put them together 1, 3, bracket them, 2, 4, 3, 5. Okay. So all these are called ordered pairs. You can put a bracelet bracket for them. Okay. You can put in this bracelet bracket for them. Let me put in here as well. Okay. So that I can slowly, what do you call that? Later I'll send out this file as well lah. Okay, let me do a quick check that I am recording the session for those who request for it. Oh yeah, sorry that I didn't see you request to come in. Okay, all right, so let's move on. It's recording now. Yeah, so this one, right, we I will send out the file later to those who needs it as well. Okay, so let's move on to the next part. Okay, so back to here. All right, so ordered pairs. So why do you need to know that it can also be represented in ordered pairs? Remember when exam question, they may give different information, and then you must know how to interpret those information, okay? So that's why ordered pairs is one of the way that they can test you, okay? And then the last one is by graph. So remember when it's by graph, right? The X and the Y axis is the same. So that's why the X is always the object. Okay, whereas your Y is always the image. So as you write this one, 1, 3. So you always start with 1 and then 3. So to represent that there is this one, right, you just do like your coordinate cross. And then 2, 4, which will be your object 2, image is 4. Just do like that. And then 3, 5, same thing. Okay, so as a conclusion, okay, so for this first part, remember that for relation, there are how many types here? Who can tell me? How many types? We have 4. Am I right? Yes. Okay. We have 4 types. Thank you. Ainsley is the one answering. Thank you, Lain also. The rest also can catch up. Yeah. Yeah. So there are 4 types of relation, namely one to one, one to many, many to one, many to many. Okay. And we can represent them in 3 ways. That is arrow diagram, ordered pairs, or by graph. Okay, so I think should be no problem to this point of time, right? Okay, maybe there's one question, yeah. Teacher, when to put bracelet bracket, when not to put bracelet bracket for ordered pairs? So for ordered pairs, we always encourage bracelet bracket. Okay, because why? We want to show that these are the object and image that we have. Okay, like that. Okay, so we always write down bracelet bracket to show that there is in one set. Okay, remember, bracelet bracket only used in set form. Okay, set form. So that's why if you want to say that these are the sets of object and image, so that's why we use the bracelet bracket. Or sometimes when you're asked to give range, you also use a bracelet bracket, right? Okay, so that is about bracelet bracket. Okay, for ordered pairs. Okay, so next one will be, we move on to here. Okay, so done with the relation. Okay, so we come to the terms. Okay, so all this so far is still what do you call that now? Reflecting back to the form 2. It's the same thing. So let's say here we have set A and set B. So set A, we usually call them as domain. So inside domain, what do you have? Inside domain, you will all have the object. Okay, she came in already. Okay. So set A is called domain. So domain is where all the object lies. Okay. And then the set B is the codomain. All right. And each element in domain is called object. And let's say here we have how many objects? 1, 2, 3. So the objects are 1, 2, and 3. So you can see here the difference here to the question that I asked just now. When to put bracelet bracket, when not to put, right? So you will see here when you want to tell that this is a domain, okay, so you have to put in 1, 2, 3 in a bracelet bracket. Whereas if you just want to tell what are the objects, then you will say that the objects are 1, 2, and 3. Okay, so the form 4, do you remember that in your test 1, this is what I have tested you. I asked you to list down the object. So remember, whenever just listing down object, you are just listing down what are inside. Okay, but when you're asked what is domain, you have to put bracelet bracket to tell me that they are all in the set of domain. Okay, so same thing here. In codomain, you will have 3, 4, 5, 6 because they are all in a set of codomain. Whereas the image, okay, you will have here, the image will be all the images here, 3, 4, 5, and 6. Okay, so just like what we say here, each of the element in the codomain is an image. So 3, 4, 5, and 6 are all called image. Okay, but when you come to the keyword range, we said that only those that contains the image, okay? The set that contains all the images that are matched is the range. So here in this case, set 6 is not matched, so it is not in the range, right? So all these we have learned before. So far, so good? Is it okay? Can I see thumbs up from everybody so far? Oh, Hester is in. Yeah, I should have 46 here at the moment. Good. Good. Okay. So which means there should be no question, yeah? So in my lesson, always you have to raise hand, yeah? Remember that? It seems to every classes. Okay. So good. All right. Who is this Not? What? Your name is called Not. Good. All right, let's put down our hand now. Okay, thank you everyone. So these are the basic ones. Hope that from there you build your confidence. Okay. So let's move on. All right, so this will be domain. Okay, so remember to get this term correct. So in the question, okay, when they want to, sometimes they will be very specific, right? They will ask you that, okay, so the domain that they are interested in. So sometimes when they give you domain, right, they will also like to give you X. Maybe they want from -1 to 5, for example. So because there are so many numbers, so they are not representing it in a arrow diagram. They may just ask you to, for the domain where X is including between and inclusive of -1 to 5. Okay, which means now your X will be, the object will be -1, 0, 1, 2, 3, 4 until 5. Okay, so always remember that. So this will be one way where they will tell you the domain that they are interested in. Okay, so you have to also know how to interpret that. Whereas codomain or range, we rather say, okay, so because this one, we will say it as, for the range, we always say that it will be fx. So usually the question will be telling you that they want the range from, let's say, -2 to 3. Okay, so in that case, they are interested in your fx being what number? -2, -1, 0, 1, 2, and 3. Okay, is it clearer? All right, so this is how you may have seen the question sometimes like that. So you have to know how to interpret lah. Okay, and then let us just do a quick recall that all the items in A here, okay, we call them as object, all in B that we call them as image. Okay, is it good? So now let me put this in. I'm going to move on. Okay, so now let us go on to function. Okay, so these are generally applies to all the relation. Okay, to all the relation, whenever you have a domain, there is always a codomain. But now we move further and focusing only on function. Okay, so function is what? Function is a special relation where every object has only one image. Okay, please highlight it. Okay, function is a special relation where every object has only one image. Okay, remember the first part of this chapter where you are asked to justify whether they are function or not. So when you are asked for a reason to support, you have to always say that it is a relation. Why? Because every object in the domain has only one image. So that's the justification. Okay, and then here is just extra lah. A function is also known as a mapping. Okay, a function is also known as a mapping. So from the type of relation we have learned, only one-to-one relation and many-to-one relation are function. Okay, so back to this one here. Okay, so you can put a star besides this one, say function, and then put a star here, say function. So only one-to-one relation and sorry, this one, many to one, yeah, not this one, sorry. One-to-one relation and many-to-one relation has one-to-one. One object has one image. Okay, you see here, like this one, definitely no problem, one-to-one, where this one will be one-to-one. Even though they share the same image, but still one object has one image. So that's why we say many-to-one is also a function. Okay, so this is where we go. Only one-to-one and many-to-one are function. Okay, also highlight this, yeah. Okay, and then function notation, we always use small letter. Okay, you can have F, G, H, okay, or some other alphabets, M, N, O, P, Q, doesn't matter. Okay, as long as you write them correctly, where you write them F dot dot X, arrow to 2X. So we are reading it as function of F that maps X onto 2X. Okay, function F map X onto 2X. Okay, so the same thing here. The same thing here, you have Fx equals to 2x, or you can write it this way. All right. Okay, so the same thing you can apply is that if you have G double column X, okay, going to 3x plus 1. So you can say that the function G map X onto 3x plus 1. Function G map X onto 3x plus 1. Okay, so this is to help you when you have to present maths orally. Okay, you have to know how to read them correctly. Okay, because when you're learning this, right, this is a very basic in calculus, even you go up to university. Okay, so when you're asked to present maths, okay, explain, so you won't like put a shame on yourself that you don't know how to read that. Okay, so we said function G map X onto 3x plus 1. Okay, is that okay? All right, so this is two ways of writing it. The first way you put like what we do. The second way is you can just read as Fx equals to 2x. Okay, so this one will be two different way to write it. Okay, now so let's go on to the case now, where I want you to always remember, yeah, when we have case like that. Okay, let's back to this one. Okay, you have f function. Okay, okay, so when x is over here, we always say that x is the object, isn't it? Okay, let me erase this too. Okay, so when we say x is the object, so these are the objects, right? Okay, so what we do to the object, okay, so I write here first. So this is the object x. So what happened is the object x has become 2x. Okay, let me use another color for the image. So 2x is here, which means what happened to x is that under the function of f, right? Okay, under the function of f, the x has become 2x. So I repeat, under the function of f, the x has become 2x. So which means the object is x, the image is 2x. Okay, or we can say that when I have my x here, okay, when I have my x here, my object is always my fx. So I repeat, yeah. So let me put it into a table. Okay, so we always have our x, which is the object. Okay, and then I will have my fx, which is in red here. My fx will always be my image. Is it okay? Yeah. Oh, my house start to rain here. Is this the same as your house? Oh, okay. Strong wind as well. Okay. So sorry, yeah, I heard someone is coming in. Can I just admit? Yeah, Tanisha. Okay. Good. So let's continue. All right. So here, we were at this part. Okay. So I just want to clarify again. The x are all the objects, and then fx are the image. Okay. So that's why here, when you want to map, right, the object is all here that I highlight in X. Okay, the highlighted yellow color part is all the objects, whereas the image is actually fx, which means this whole thing is also fx. Do you see that? This whole thing is also fx. So fx is the image. So image equals to 2x. Okay, and the object is just the x here. All right. So don't confuse it. So like what we say here, I can give an example like 2x here, which means when you have 2, okay, let us start with a blue color. Okay, when you have 2, it becomes 4. When you have 3, it becomes 6. When you have 4, it becomes 8. So the objects are all here, 2, 3, 4. Whereas the image are all the numbers here, the 4, 6, and 8. Okay, so shall you write in what do you call that? Function notation, we will always write it this way. Okay, meaning when you have f, okay, let me use black color to be this one. Okay, when you write f x, you get 2x, right? So now our object here, we have 2. So we write as f2 equals to 4. We write f3 equals to 6. Do you see that? Okay, so it's a representation. So the objects are all here, whereas the whole f3 is the image. So image, I use red. So this whole thing is an image. And 6 is also an image. Where is the object? You. Let me come home. I come very strong wind, my house here. Okay, so F3 we get equals to 6. So if you look at it, right, F3 is also an image. 6 is also an image. Okay, and the only object is our 3. Okay, only 3 is the object. Is it okay? Do you get me now? And of course, the 2x here, this x is also object. Okay, so put it to a clearer one. Okay, so just now I said fx equals to 2x, right? So how can f2 you get 4? because you substitute the 2 here. Am I right? You make your object here 2. That's why you are getting 4. Is that clearer? Let me write here equals to 4. Okay. And then if I have here, okay, if I have here F3, like I said, it's equals to 2 times 3 equals to 6. Okay. So the object here, wait, Mimi, Tong Chang. Okay. Sorry, my baby cry already. Wake up, cannot find mommy. So object is 2. You substitute in the object. Okay. Object is 3. You substitute in 3. Is that okay now? So that's the basic concept, yeah? Let's move on. Okay. So that's what we have done here. F1 equals to 2 times 1, where you get 2. Okay. So this one should be okay. Okay. Okay, let me put it here. All right, so let's move on. Okay, so let's see example 1, basic one. They want you to find the image of -1. So what you did here, you just put in the x here become -1, isn't it? So you will have 3 -1 minus 2. So 3 times -1, you get -3 equals to -2. So this is what means by they ask you to find the image of -1. Okay, so when they ask you to find the image of -1, okay, it just means that they want you to find the image when this is the object. So this will be the object. Blue pen, red pen. So this is the object. Okay, that's why they will ask you to find what is the image. That's why when they want the image of -1, you know that this whole thing is the image, right? When they want to find the object, okay, the image of -1 means -1 is the object. Okay, so you will put in here, this one is the object, become -1. That's why when you put in f -1, okay, all the object become -1. Do you see here? So 3 times -1, you get equals to -2. So you will have here, and then you can solve. So the very important thing is to interpret correctly. Find the image of -1 means the image is what you need to find, and the given -1 is the object. So you just substitute it in the object. Okay, so this one so far so good. When they ask you for part B, find the object which has the image of 4. So which means this is the image. Okay, they want the object. So when they want the object, which means they want the x value. Okay, they want the x value here, and then they ask you to find image. So here, the image of 4 means fx equals to 4, right? Which means here, they don't know what's the object. Oops. Which means if you draw like that, right? Here, they don't know what's the object, okay? But they know that it will have an image of 4, okay? So what happened here is your f will map all the x to the 3x minus 2. So we can say that 3x, fx is equals to 3x minus 2. And at the same time, we also say that fx equals to 4, isn't it? Because they are all here fx. They are all inside here fx, okay? So that's why you will say that when you compare these two, you will see that your 3x minus 2 actually equals to 4. 3x minus 2 actually equals to 4. Then from there, you can solve the question already, isn't it? Equals to 4, okay? So you will have 3x equals to 6, x equals to 2. Is it okay? So that is how we solve when you are given the image 4 and you're asked to find the object. Is it so far so good? Am I too slow? All right, let me put it here. Okay, can I see hands if so far so good, or you would like me to go faster? Oh, and Zhenqing should be in, right? Zhenqing, are you in already? Should we in now because I didn't admit you. Is Gan Ching Ching in? Okay. Sorry. All right, thank you. You can put down your hand. I just want to check whether Gan Ching Ching is here or not. Oh yeah, here she's here now. Okay. All right. So here you go. Is it okay or you want me go faster? Can? No feedback means okay lah, huh? So I just moving on. Yeah, can. You want faster? Yup means what? Okay, let's move on. Okay, so that's the very important part. Okay, and then okay, let's say you have example 2 here. Okay, fx equals to px plus 3, f4 equals to 5. So now they start to give you 2 hints. Okay, so what you did is you can see here this hint f4 equals to 5 is meant to give you the object and the image. Okay, so what you can do is you know that when f4 equals to 5, which means the object is 4 now, so you can put in the 4. So it becomes 4p plus 3. And then you also have f4 equals to 5. So that's why we say 4p plus 3 equals to 5. So now you get 4p plus 3 equals to 5. Then you can solve for p. Okay, so this is one part. Okay, so after this one, right? Okay, I want you to also find out. Okay, let's say we continue from this one. Okay, question 2. Let me take this into my snipping tool. Okay, I want to add on to this, but C. Okay, what if, now we have this one, right? Okay, what if I want to add on part B, because here the question just asks you to find the value of P. So let's add to a part B. Okay, let's do it here. Okay, part B. Where's my this one? Okay. Okay, let's add on to part B. Let's say find also the image. Or we say find the object that maps to itself. Okay, write down everyone. Find object that map to itself. Okay, I remember you see this before, right? In the textbook, find object that map to itself. Okay, so how do we do that? So now, write down again from part A, we have find out that our fx is equal to, you have, because we now find out that our x is actually half, right? Going down a bit, yeah. So we have half x plus 3. Or we can also write down that it is, okay, x plus x over 2. Okay, x over 2 plus 3. Okay. So everyone, please write down. So we add on to the question, okay, that find object that map to itself. Okay. So here, that means you want to find out, okay, map to itself here means that if you have 1, it maps to 1. 2, it maps to 2. Things like that lah. So you want to find out the object that maps to itself. Okay. So which means now you want to find out which one, the x, is mapped to x. So you want to find out what is x. Is it okay? Okay. So now what you have to do, when you want to find out that an object that maps to itself, right? What do you usually do? You will let the image become x also. Do you see that? So which means here, when map to itself, right, which means fx equals to x. Is it okay? This is the key idea here. Okay, fx equals to x. Okay, that's the key idea here. Because when mapped to itself, that means the image equals to x itself. Okay, so what do you have here? Your fx equals to x over 2. And then you also have your fx equals to x. Can you compare these two now? Oops. You compare these two now. Okay, so conclusion that we can make from here is that, I use blue, our x over 2 plus 3 is equals to x, isn't it? Because you are given fx equals to x over 2 plus 3, and you want to find the object that maps to itself, which means fx also equals to x. So now you can say that x over 2 plus 3 is equals to x. So far, so good, this step? Then you can start to solve for x. So x, you want to group all the x together, because you want to solve x, you have to put all the x together. Okay, so I would rather put my x here. I minus the x over 2. Why? Because this is 1x, this is half x. So 1 minus half is easier. So I left my 3 here. So 1 minus half, you left half x, right? Half x equals to 3. So when I want my x here, I have to times 2 on both sides, remember? Why times 2 on both sides? Because I need to get rid of my 2 here. Okay, so in the end, I will have x equals to 6. Do you get that? So which means if I put in f here, 6, I will get back 6. Okay, let's try. Okay, if I put in f6, I get 6 over 2 plus 3. So I get 3 plus 3. I do get back 6. Isn't that fulfill the given criteria now? Find the object that maps to itself. Is it clearer now? Okay, so this one is a star question. Why? Because it's popular. Okay, object exam like to ask. Okay, so any more questions so far? So this map to itself, I'm going to put it here so that you have some time to write down yourself. All right, is it good? Let's move on now. Okay, so we complete this one. Okay, example 2 is just another example. Okay, where they can give you all sorts of things lah. Okay, but I choose this one because why? You can see here gx is equals to 2x over x plus m. So again, you have the unknown m. Okay, so you have to find out m when you are given one clue like this. Okay, so what does it mean by 3g2? So whenever an unknown is put in, a number is put in front, right? That means it's multiple. Okay, so if g5 equals to 3g2, they ask you to find the m first, then hence find the image of 4 and find the value of x such that the function g is undefined. So this is another popular way of asking the questions. Okay, so let me take this out. Okay. All right. So first thing, find the value of m. So always do like this, underline the question, because a lot of you will forgot to answer the question. Find value of m first, then only image of 4 and the value of x when it is undefined. Okay, so let us start to solve the question now. I'll go here by finding m first. Okay, so let us write down here that okay, we have gx is equals to 2x over x plus m, right? So the hint that they give us, the object is 5, okay, equals to 3gx. Okay, so I write down here, they give us that g5 is equals to 3 times g2. So those you can solve on your own also. So g5, that means my object is 5, right? So my object is 5, which means all the x here. Can you see here? When this is x is 5, all this will become 5. So this is my 5 now. So it's going to be like 2 times 5, isn't it? Then over 5 plus m. Is it clearer? So now I was given that when I know my object is 5, I substitute in. So I get this part. Okay. And then the second part that I have here is 3g2. Okay. Which means I have to 3 times my g2. So g2 again is my object. My object is 2 now. Am I right? Okay. So g2 here refers to the same function again, just that now it has become 2. My x become 2. Do you get me? And over 2 plus m. Okay. So here, what do I get? So 3 is outside. 3 is outside, because it's the whole g2 that's times 3. So I put it outside. So this one will become 4 over 2 plus m. So remember, the something outside can multiply in here. So it becomes 12 over 2 plus m. So this is 3g2. Okay, so recall back the relation given here. Okay, recall back the relation given here, whereby G5 is equals to 3G2, right? So which means this thing here is G5, which means this thing here is G5 is the same as my 3G2 here, which is this. So which means now I can make them equal. Okay, so I try to make them equal here. Okay, so let's go into 2 times 5, 10. 10 over 5 plus m equals to 12 over 2 plus m. Okay, now to solve this one, right, 2 layer cake on each side, you cannot do anything but to cross multiply. So cross multiply will be this one cross up, this one cross up multiply. So it will become 10 times 2 plus m equals to 12 times 5 plus m. Okay, so this one, basic maths, remember, you have to expand to multiply in. 10 times 2, 20, plus 10 times m, 10m, equals to 12 times 5, 60, plus 12 times m, 12m. So to solve m, we group all the m together. So you can choose to bring 12m here so that it becomes minus 12m, but in the end you will get negative, or you choose to put the 10m to the other side, which will minus 10m, and you will get positive 2m. Am I right? So this is some decision making. It's not wrong. It's just that you will end up having negative, then later you divide negative number lah. Okay, it's the same. So let's say now for me, I'm going to see here that I have 12m here, I minus 10m. So at the same time, originally I have 20 here, right? So my 60 cannot be there, so I minus 60 here. It's the same thing. Okay, so 10 minus 12 minus 10, they are the gang of m, then you can minus them. So 12 minus 10, you get 2m, whereas 20 minus 60, if you need calculator, please do so, otherwise you will get negative 40. So you can rewrite them, 2m equals to negative 40. So your m will be negative 40 divided by 2. Okay, so you will get straight away negative 20. Okay, I do it slowly. Okay, so negative 40 divided by 2, then you will have negative 20. Is it okay? So this is just first part. Okay, now you found m. So you see how cruel is this at maths, huh? You know this part, you can only have 3 marks here, or 2 marks mostly, meaning where's the first 1 mark? 1 mark will be here. I use black. The first 1 mark they will give you here, and then another 1 mark will be here. Okay, after you do so many steps, you only can get 2 marks. Yes, you're right. Okay, then can I move on? Am I too fast? Can I see hands if you are good? Can all can follow. Very good.
Teacher.
Yes. Wait. I have to put your
Teacher.
voice louder. Yes. Can you speak louder? Who is that? Can you speak louder?
Teacher.
Someone call me teacher. Oh, Jasrine. Yes. Good morning.
My Wi-Fi
What's your
is so
question?
slow.
Okay, no worries. I have recorded this. You can replay back at any time. Okay, so no worries about Wi-Fi. Okay, any more question? The advantage that if you attend now is that you can ask question at any time. Okay, I'm just going back to the very basic one. Then we will go to the composite, then the inverse. Okay, so let's move on. Okay, so here image of 4. Okay, so which means now they have image of 4. So this question itself, so if there's no any question, I move on so that we can move faster. So image of 4 will be, 4 is what? Then they ask you to find image, which means the 4 is the object. Right? So which means this 4 is the object. So in your mind, you should have this picture already, my dear, everybody. Okay? You should always have this picture that now you have your X, and Under function of g, it is mapped to the gx, whereby all the gx here will be 2x over x plus minus 20, sorry. X minus 20. Is it okay? So this is what you have in your mind now. So now when your object is 4, okay, so which means they give you 4, they want to find the image. Okay, so this is what another mapping here. So you have to find out what is this lah. So which means when your object is 4, that is very simple, which means your x is 4, right? So you're going to put here G4. So I'm solving part A now. So G4 meaning I just have to put in all my object become 4. So you will see that once you get the concept correct, it's very easy to solve all the questions. 2 times 4 over 4 minus 20, right? So you're going to get 8 over this one minus 16, and you're going to get negative 1 over 2. Is it okay? All right, 8 over minus, yeah. So you get negative 1 over 2. And then part B, what happened is that,
Need
okay.
to copy anything.
Come again?
Need to copy anything.
No need. Actually, this one, you want to copy is up to you. Why? Because this is extra explanation, like diagram like that. I'm trying to help you to form a more firm concept. Okay, concept is very important, so that if you have something like this suddenly pop up, then you know that this is actually 3 times gx, right? Then you won't panic. So that's why I try to go back to the basic and explain. So to copy or not copy, I leave it to you because you have the hard copy. Jess is from Form 5, you had the hard copy. The Form 4 also, you should have your hard copy actually. So I have already mentioned that because I handle cases after my 5 Chem 1 class, so I have only half an hour time by right. It should be okay to distribute to you all during that time. That's why I asked Kristen to help me to ask who want to attend and all that. But end up because there's sudden pop-up of a discipline case that I have to handle, so that dragged my time, and then you already dismissed, so I couldn't give to you. So I have already give soft copy to the Form 4 as well. So if you need to copy, you can always do that. Later on, I will send to you this one. All these that I have previously explained. So you see which part is helpful to you, then you tailor it to your own needs. Do you see that? Because this class now it's combining all the 4 classes. So you have different basic with you. Okay, so I just move on. You can ask question at any time. Okay, get it everyone? So that you learn it. This is the way how university students learn, because everybody has their own basic. So it depends on you whether you want to copy or you want to do some note, you want to highlight, it's all up to you. All right? Yeah? So let's move on. So now we go on to undefined. Okay? So the keyword, again, undefined. So to recall back this part, do you remember that usually you will have cases where they tell you, let's say we give another example here, hx, okay, they will tell you that hx is equals to 3 over x, right, where x not equals to 0. When you solve a lot of questions, you always see like that, right? So why do they want to mention that x is not equals to 0? Because if you put h0 inside, okay, you're going to get 3 over 0, right? So if you press calculator, 3 over 0, you always get math error. Okay, so why is it called math error? Because the math error here means undefined. Okay, math error. Okay, so it means undefined. So that's why when we try to avoid to make our denominator 0. Okay, so here this math error actually means undefined. Okay, let me write it here for you. So that's why when we said that when the function gx is undefined, okay, that means the x cannot be equals to 0. Okay, I should say it like that. Undefined means the x is already equals to 0. Okay, so that's why the value of x such that the function g is undefined, which means we want to look at g0. Do you get me? Okay, Then now you put in G0, right? You are getting 2, 0. Oh, no, I cannot say like that. Sorry, it cannot be G0. It's just the bottom part. Do you realize that? Okay, sorry. This is confusing you. Okay, let me erase all first. Okay, that means the bottom here. Okay, let me write back in black, blue. Okay, so let me do it here. Okay, for Gx, this case where you have 2x over x minus 20. So in order for to be undefined, right? Remember this part? We always say that the denominator is equals to 0, just like what you have here, this one. Okay, that's why you always mention x cannot be equals to 0. So in this case, right, you have to let x minus, okay, whatever you have as your denominator, you put them as equals to 0. X minus 20 equals to 0. Okay, so you let them become 0 first. Then you know that your x equals to 20. Okay, so that means the value of x, when the x is 20, the function g is going to be undefined. Okay, so you can try it out here where you put g20, where you have your 220 over 20 minus 20. Right, so you're going to have 40 over 0, which means this is undefined. Do you get me now? You can always do a double check like that. Is it clear? So, which means the final answer is x is equals to 20, so that the function is undefined. Okay, is it clearer now? So I repeat, the value of x such that the function g is undefined. So which means you want to know what value of x will make the function g undefined. So that's why you will make your numerator become, denominator become 0. Okay, so whatever function is given, as long as the denominator becomes 0, then that value will cause the whole function to be undefined. Is it clearer? So this is the answer here. All right. Any questions so far? No? Okay. So this is when the function part to find value of m first, then we found it. Okay, so this question, if you ask me, teacher, how many marks? 5 marks. Okay, 4 marks only. Why? Because this part is given 1 mark, value m 1 mark, and then your image of 4 is 1 mark, and then the value of x is 1 mark. Okay, that's it. So only 4 marks questions. Is it okay? All right, let's move on to the next one. We go slightly faster. Okay, so now exercise time. Can I ask you to do maybe just 2 questions? Okay, we try questions 6 and 7. The rest I will send to you the solution. Okay, you can solve and then you can always refer to my question, my answer. Is that okay? Can I ask you to solve, let's say, number 6, number 3, and number 7? Okay, do it now. 3 and 7. I will do 3 and 7 now.
MB
Okay.
what? I mean M
No,
what?
no. Not in now you use foolscap paper, everybody. You can use foolscap paper, okay? And then you can put here extra class, and then you put in today's date. You can file it up in your file. No matter which class are you from, you can always do this because I believe every class has a file. Okay, so extra class, then you write down today's date is the 2nd of July. Okay, so you just solve these 2 questions. Now the time is 8:32. Okay, I will give you 5 minutes time, should be enough. It's a quick question here. Okay, 8:32. Then I will discuss, then we move on to the inverse. All right, So I will go and take a sip of water, then I want to continue to give you the answer. Can you do it now? Okay, thank you. I will pause the recording. How to pause recording?
Peter, I don't think you can pause recording because if you pause it, you'll just stop the whole recording entirely.
Okay, then I just stop then.